All right, so here we have a Carrier comfort heat pump with a traditional fan coil and emergency heat. What we have seen is that we've established our temperature probe for the liquid on the indoor coil on the liquid line as a reference point. We have our return air psychrometer, our supply air psychrometer. Right now, when calling for heat, we only have 1.2 degree temperature rise, which is negligible if anything. Then what we'll see here is that, let's see here, these are my temperatures, are my pressures outside. 59 on the suction, 105 on the liquid. That's on the True Suction, as we'll see. Took all day. Samsung froze up with the thermal imager. Right now it's on defrost, but I'll get out of it momentarily. And what I want you to notice is I'll put this one right here. Where's this? Let's see. So we got like 21.5. And I'm gonna put this one right here. As soon as it starts up, we'll have a reference point. My 87.7, 193. Right there's the True Suction line. I have there my temperature clamp, and then I have here on the liquid side my pressure transducer. So here they are. Now, what I want you to notice here is I'm going to add 2 more sets of probes. So on here, we're going to go to the refrigerant side containers. I'm going to put 2. I have inside there 2 probes, one on the bottom, middle, True Suction, and then one on the top, discharge. So we'll go ahead and do that now. So we're going to go back here. I'm going to scroll down. And now I'm going to make sure that I have it linked to the appropriate one. And one proxy that you can do to see if you have it linked correctly is look at the difference. So this one is the one on the inside, the 80 point. So this one here, this 24.6, is that True Suction. That 54.8 is on the inside. And then here it's at the actual reversing valve. Notice that difference? It's very minimal. But let's let it start up right now. So across that reversing valve, note the difference, less than 10 degrees. And this here, 21.5 when the reference outdoor temperature was. $20.2. Okay. So 20.2 20. As you can see, there's no discernible difference occurring. There's no absorption of the British thermal units by the refrigerant. So again, look at the temperatures after the reversing valve. 27 at the true suction side, 40 at the top. Now we'll go ahead and start taking our electrical characteristics. So here, we have 3.97. The blue one is 400. 4.35. And 0.58 for the condenser fan motor. Now, look at the difference at the reversing valve. No bueno. So, compressor is not performing its work. And we can also determine that by the lack of a temperature rise on the indoor air. This is your return. This is your supply to 1 degree temperature rise. This is my true suction 76.7. This is my liquid 93.1. My temperature clamp on the 20.8 dot one. And that 49 is on the inside. This is at the actual reversing valve right there. So we have a bad compressor. Alright, now just to do a full round out, we'll go ahead and check the voltage coming in. .4. 246.4. I checked across each terminal previously, there was no voltage drop. I checked the capacitor, that's fine. So that compressor is not performing work and needs to be replaced. I would also perhaps replace the reversing valve to assure myself the proper function. Have measurements. We'll go ahead and solidify this right now by creating that PDI. Okay, here's our measurements. There you have it. Everything is crystallized. And here's the data plate. So this is a relatively recent installation by a third-party company. Homeowners have just moved in the past year, and it seems like it may have been a bad vacuum procedure or something because the compressor had a short lifespan.
Isolating the refrigeration cycle in 20-degree weather. Step 1. Kill the emergency heat. Without heat strips, the truth came out a negative 0.9 degree temperature difference, or rather, temperature rise, which is negligible. Probed the reversing valve directly to see what the compressor was actually doing at the source. Discharge was only 29.3 degrees. At these pressures, that's a complete loss of compression. Electrics are solid. Capacitor hit a perfect 34.9 microfarads. It's not a start issue. The motor's spinning but pulling a no-load 4.09 amps. No work is being done. Verdict: mechanical compressor failure. Don't let auxiliary heat hide a dead refrigeration cycle.